and summation notation. Okay, so first of all, let's talk about sequences. What is a sequence? It's a list of numbers. So a sequence may be 1, 3, 5, 7, ... This is, if I put ... it's an infinite sequence. But what if I have 1, 3, 5, 7, ... a sub n? Stop. This is the general term. Since I stopped here and I did not continue with 3 dots, this is not an infinite sequence, it's a finite. It does not go on forever. It starts at 1 and it stops at the general term. And I can give n such and such number where it stops. But this is a finite sequence. Sequences can be given to us in several ways, or can be presented in several ways. Okay, and I'm just going to share my screen. Okay, so one possibility is I am given the general term 3n plus 2, 3 to the n, and so on and so forth. Another possibility is when we are given a recursion formula. So we're going to look at both situations. So I'm going to start, let's say, with number 2. We're given the general term a sub n, which is 4n minus 1. And the question is very simple. Write the first 4 terms. So if we are not told anything about n, we have to assume that n is 1, 2, and so on and so forth. And they want the first 4 terms, meaning a1, a2, a3, and a4. What does this mean? Very simple. N is 1. 4 times 1 minus 1. N is 2. 4 times 2 is 8, minus 1 is 7. N is 3. 12 minus 1. And n is 4. 16 minus 1. These are the first 4 terms of the sequence, meaning 3, 7, 11, 15, and so on. Good. Let's choose another example. We are asked to find the first 4 terms of each sequence, from 1 through 12. Anything you'd like to pick to illustrate with another sequence, another general term, how to find the first 4 terms of the sequence. Anyone would like to pick? Or I will.
Can we?
Which one?
Number 12.
Number 12 it is. Very good. So the general term in this case is negative 1 raised to n plus 1 over 2 to the n plus 1. Perfect. Perfect pick. Good. Again, we're asked to find the first 4 terms, a1, a2, a3, and a4. 1 plus 1 is 2. Negative 1 squared is 1. 1 over 2 plus 1 is 3. That's the first term. N is 2. 2 plus 1 is 3, but negative 1 to the third is negative 1. 2 squared is 4. 4 plus 1 is 5. 3. 3 plus 1 is 4, but negative 1 to the 4th power is positive 1. 2 to the third is 8. 8 plus 1 is 9. 4 plus 1 is 5. So the numerator is negative 1. 2 to the 4th is 16. 16 plus 1 is 17. So we determine the first 4 terms of this sequence. 1/3, negative 1/5, 1/9, and negative 1 over 17. These are the first 4 terms of the sequence with a general term, negative 1 to n plus 1 over 2 to the n plus 1. All we have to do is replace. Good. Now let's look at the other set in which they're giving us a relationship. And they say the same thing. Write the first 4 terms. But they're giving us the first one. So we only need to determine a sub 2, a sub 3, and a sub 4. Okay? So let's choose one and see how this works. When we are given a formula, we're not given the general term in a clean way, but in a convoluted type of way. Anyone would like to pick one from 13 through 17? I'm sorry, 13 through 18?
15.
Okay, so let's look at 15. Thank you. We have A1 is 3, and we are told that the general term A sub n is 4 multiplied by the previous term A n sub 1, and n is greater than or equal to 2. Of course, because they are giving us A1 already. So, A1 is 3, and I am told any term depends on the previous one. If this is 5, this is 3. I'm sorry, if this is 5, this is 4. If this is 10, this is 9. So the 10th term is 4 times the previous term. That's what it means. So A2 is 4 times 2 minus 1 times A1. So the second term is 4 times the previous term. The third term is 4, 3 minus 1, times the previous term, which is 4 times 12, which is 48. And A sub 4 is 4 times A sub 3, because that's what the formula is telling us. Any term is 4 times the previous one. A sub 4 is 4 times the previous term. So this is 4 times 48. What are the terms of this sequence given to us as a recursive formula? It's not clean cut. It's just a relationship based on the previous term. What are the sequence? Are the first 4 terms? 3, 12, 48, 192. Okay, see if we need another example to look at another recursive formula. Anyone would like to pick? Okay, I will pick 18. Do you find this easy?
I think it is.
Perfect. A1 equals 5. A sub n equals 3 times A sub n minus 1, minus 1, of course, for n greater than or equal to 2. Good. So now let's understand this formula. A sub n equals 3 times the previous term, but minus 1. Okay. So A sub 2 would be 3 times A sub 1 minus 1. But A sub 1 is given to us. 3 times 5 is 15. 15 minus 1 is 14. Now a sub 3 will be 3 times a sub 2. Because if this is 3, this is 3 minus 1. So this is 8 sub 2 minus 1. So 3 times 14 is 42 minus 1 is 41. So we have the first term, we have the second term, we have the third term. So now we want the fourth term. 3 times the previous one, but minus 1. So 123 minus 1, 122. So what are the first 4 terms of this sequence? 5, 14, 41, 122. Any questions? Okay. Let's take a look at something called factorial. What is factorial? Okay, so if I have 4 factorial, the symbol is the exclamation mark, and we read it 4 factorial, 4 factorial. It means 4 factorial means 4 times 3 times 2 times 1. 4 times 6, 24. 6 factorial. 6 times 5 times 4 times 3 times 2 times 1. 12 factorial. 12 times 11, dot, dot, dot. I'm not going to copy all of them. Times 3 times 2 times 1. By convention, 0 factorial is 1. And you can say, but 1 factorial is also 1. True. So by convention, 0 factorial and 1 factorial are equal to 1. Let's simplify some factorial expressions. 23 through 28. We want to simplify some factorial expressions, and then I'll show you with a graphing calculator. Do I still have time? Yes, 5 minutes. Anyone would like to pick, or I will?
25.
Very good. 25. 16 factorial over 2 factorial and 14 factorial. Perfect pick. I'll show you with a graphing calculator. However, 16 factorial may or may not, the calculator may or may not be able to calculate it. I don't know. But here's the easiest way. 16 factorial, 14 factorial, 2 factorial. These two, 16 and 14, 16 is the biggest. So I'm going to write it as 16, multiply by 15, and I know what follows. 14, 13, la la la. Instead, I'm going to do this. Because 14, 13, ta ta ta, 3, 2, 1 is 14 factorial. Why did I stop at 14? Because of this. 2 factorial is simply 2, and 14 factorial, and I got rid of 14 factorial gracefully. I simplify by 2, and I only have 8 times 15. 120. Done. So I always look at the biggest, and I stop at the next term, if you want. I could have continued, and you could have deleted all the 14 through 1. But why? When I see that I can stop at 14 factorial and get rid of it. How do I do this with a calculator? Very simple. So let's say 4 factorial. It's under probability. And this is number 4. So we already know we calculated 4 factorial to be 24. Now what if I want to calculate what I just looked at? So I have 16, and then go to math, and then probabilities, and then number 4. I have 16 factorial. I divide by, in parentheses, careful, 2 factorial multiplied by 14 factorial and close. When I hit enter, I have to get 120. Sometimes, as I mentioned, the calculator will not be able to determine a big factorial number. So let's see what we get. We got 120. I'm curious to see if it calculates 16 factorial. It may or may give us an error. It may. Look at this. It's 2.1 times 10 to the power 13. It's such a huge number, it's unbelievable. I cannot even read this. But 2.1 times 10 to the 13th power. But if you get to something like this, factorial, the calculator will probably give us an error. It cannot handle this. Okay, it was able to. I doubt that it can do this. It cannot. It's not possible. It's such a huge number, it has an overflow. So this is how we handle factorials. Any questions? I'll stop, as I promised. I do have just a